Good morning, everyone, and thank you very much for being here in this third podcast related to standardization. My name is Konstantinos Grevenitis, and I'm a software developer and I work for Holonix, who today is the host of this podcast. The goal of this process of this podcast is to discuss with other projects on how they work on their standardization processes, on their standardization tasks, and which were the outcomes that they had through them. So far, we have held two podcasts, and this is the third one, but the details will come later. So, about today. Today, we have two wonderful guests, two really strong projects. One is Dat4.Zero and the other one is Modular. Dat4.Zero is, let's say, almost completed, and Modular is in progress. Modular has completed its first year a couple of months ago. So we will have a lot to discuss about the work they have done on standardization. After their presentation, there's gonna be a set of open questions to discuss various things and highlight and spot little things that we usually skip when we are working on standardization. So, again, what is the goal of this podcast? Is to discuss with other projects about the standardization process, exchange knowledge and experience, and promote the usage of standards. Holonix leads the standardization task in the KITT4SME project. As I mentioned, we have held so far two podcast sessions. The first one was the standardization in the manufacturing sector adopting AI solutions. The second one was standardization in the circular economy sector. And the third one, the current one, is standardization and data management. In these three projects, we have had 7 guests. So if you want to listen to our podcast and get the knowledge that was shared with us, you can visit the a4manufacturing.com or the project's websites in order to have access to the podcast sessions. So, what is standardization? Based on the official explanation provided by the International Organization for Standardization, a standard is a document established by a consensus of subject matter experts and approved by a recognized body that provides guidance on the design, use, or performance of materials, products, processes, services, systems, or persons. Further standards provide for common and repeated use, rules, guidelines, or characteristics for activities on their results aimed at the achievement of the optimum degree of order in a given context. Although this standardization term is quite important and correct, sometimes it's too long and people get confused and lose the point of standardization. If we could rephrase the term of what standardization is, I could say that it is a common language, a common set of terms that are used and respected by everybody in the group. But it's not only that, it's more. It's a common goal. We are using this common language, this common structured set of words in order to achieve a very specific goal in the team. Which are the main benefits of using standards? The main benefits is that technologies work smoothly and reliably together, provide economies of scale, foster research of innovation, and keep markets open. Especially when it comes to software, I could add that it makes different systems communicate to each other without any issues, because as I said earlier, they speak the same language. Now, about the KITT4SME project itself. The KITT4SME project itself is a project that has lasted for almost 4 years and is going to finish in March of 2024. So it's a 42 months long project. It has been funded by the European Commission with 8 million euros. And 2.5 million of them have been invested into open calls with SMEs who have used the KITT4SME platform. Also, there was an offered funding. The 70% of the offer funding. There was an offer. The offer funding is 70% and equity free. There are 80 partners from 8 countries in Europe, 4 digital innovation hubs fostering widespread reach of the platform, and 4 internal pilots, 4 internal SME pilots, 4 manufacturing SME pilots are in the project. As you can see in the map, most of the companies come from Italy, but we also have partners from Switzerland, from Spain, from Germany and Poland. Now, the KITT4SME project had companies in the manufacturing field who stress test their AI adoption and readiness to fill a survey. The proposed survey relied on the 5 pillars model that considers not only the operational aspects, but also how structure and culture inside the company allow to fully exploit the potential of AI solution. The 5 pillars are the following: digital and smart factory, data strategy, human resources, organizational structure, and organizational culture. And the results were the following. So 35 companies were interviewed, and nearly half of them do not apply any AI solutions in the shop floor in the company. 33 of the respondents are defining a strategy to promote AI adoptions within the company. Only 1/10 of the companies are training their employees on digital skills, and 69 of the companies believe that the collection of data is fundamental for their businesses. And as you can see on the bottom left, several industries were involved, from aerospace to paper and from cotton to plastic. Additionally, the KITT4SME project has leveraged the network of digital innovation hubs in order to push the limits by offering to the external actors through open calls the platform itself, but also a marketplace in order to expand the platform's visibility and adoption and highlight any business potential. So if we could place what the KITT4SME is in one phrase and in one diagram, what we could say is that the KITT4SME specifically targets European SMEs and mid-caps to provide them with scope-tailored and industry-ready hardware, software, and organizational skills delivered as a modularly customizable digital platform that seamlessly introduces artificial intelligence in their production system. And as you can see here in the diagram, what we see is that we get raw data from different data sources. We store the data, and then through the AI solutions, these data sets are analyzed, and in the end, they produce useful value to the SMEs that are using the KITT4SME platform. So the pilots that we had in are the following. One comes from the injection molding sector, one from the quality sector, One, it comes from precision hand tools sector, specifically tweezers, and the last one comes from the electrical equipment sector. And all of them come with different problems, and they needed different solutions. And these solutions were provided by the KITT4SME platform. So let's start, and I will give the floor to Silvia from the Dat4.Zero project, who will explain to us about the project and all the work they have done on standardization. Silvia, the floor is yours. You can share your screen.
Thank you, Konstantinos. I am going. Let me share my screen. First of all, my name is Silvia Castelví. I am working at International Data Space Association. We are a non-for-profit association that is working in order to standardize how to share data in a secure way in manufacturing, cross-sectorial level. So in Dat4.Zero project, that is the project that I am going to explain you, we are in charge, we are leading the standardization activities. So, yeah. Okay, first of all, I would like to introduce you the project Dat4.Zero. So Dat4.Zero presents European manufacturers with a system and deployment strategy for digital enhancement quality management. The project started in October 2020, and we are going to finalize, so we are at the end because the project finalized next March. So it has been 42-month project, and we, in the consortium, we have 20 partners from 6 countries, and you can see in the slides the consortium members and also the countries of the representatives. The activities that we are developing are around 8 work packets, and you can see here the technical work package for data integration solutions, and then the work package for analytics and modeling for providing the services that allows to zero defect manufacturing. But we have cross work packets. Of course, we have the architecture definition and also the validation of the pilots that implies the involvement of all technical work packets. But then we have vertical work packets for along all the project to coping with activities like dissemination, communication, exploitation, and standardization. That is the activity that I am going to explain what we have done in the project just after finalizing the presentation. Here you can see the architecture of Dat4.Zero that is based on 5 layers from 5C architecture, where we, in these layers, we collect the data that we generate in the devices, in the sensors, and then we integrate this data in one platform, the QM platform from Dat4.Zero, that integrates and manages the data to be available for processing the data by artificial intelligence and super systems for data utilization and providing the added value services that was promised in the project. Okay, so here the data in this project is very, very important. And in order to demonstrate, we have 3 use cases from different sectors. We have one use case in automotive sector provided by Bentley. We have one use case in healthcare provided by Dentsply, and we have one use case in manufacturing sector, Versa, that builds bearings. And we have tested and implemented the solution in this pilots in order to demonstrate the impact of what we have developed. And you can see here the impact that we have achieved. We have increased the quality through from 15 to 18% of scrap reduction, but we have also increased the equipment productivity through rapid errors localization. We have reduced the ramp-up time using smart sensor, actuators, and big data analyze, and we have reduced the time to market using artificial intelligence driving smart products and process that we have developed in the framework of the project. So this is very short, the presentation. You can go to the website of Dat4.Zero to get more information and stay updated. And here you can see all the partners participating in the project. IDECO is the leader of the dissemination and communication and standard exploitation activities. And Holonix is also a member providing the DQM platform and data management. So glad to be here with you to explain in more details what we have developed in this project regarding standardization activities. So this task is a transversal task, permanent task during all project. But in order to summarize you the activities that we have developed, we have split this task in two phases. The first phase, that is awareness creation regarding standardization and standardization mapping. And in the second phase, that here you can see more in detail the activities that we have developed in the second phase of the project, starting end of 2021. We have processed all the information and present the results through all different activities. You can see here that we have organized 3 internal workshops in order to share with the partners how to address standardization activities in the projects, in order to get information from partners regarding standards implementation. And then we have also organized a workshop in order to identify the impact of standards in the project and recommendations for future standardization bodies. And another important task regarding standardization is the collaboration with clusters that are addressing standardization in the same field, in the same topic, in order to join efforts. And now we will finalize the project with a workshop with standardization bodies, with external experts, and we will report all these activities in a deliverable that will be public available. Let me show you very briefly. This is how the process has been developed, because I think it's important to share best practice and how we have developed standardization activities. So here you can see that we have initiated the project mapping, investigating how the standards are implemented in the project. And here you can see that we use this Excel in order to collect information regarding the standards, the committees of the standard that the project has adopted, which is the description of the standard, but what is more important, which is the impact of the standard in Dat4.Zero, which are the technologies, and how we can contribute to the standards, to the gap, to improve, okay, and other additional information. This is the Excel that we have shared with all the consortium. I have to say that it has been hard to get all this knowledge. So, and we have addressed different techniques in order to achieve, to fulfill all the data that was required. At the end, we get information regarding 53 standards implementation in the project. 20 of them were standards related to data management and 23 related to quality management. And then we have standards that are specific for from the use cases or specifically implemented in the use cases. And these were 7 from Sironta Dentsply use case, 5 from Versa and Bentler use cases. So regarding data management, you can see here some of the standards that were reported. Okay, for example, OPC UA for data communication, HTML from W3C, but also DIN spec from IDSA in order to implement the secure data sharing with connectors, but also standard related to data security, IoT, blockchain. I am not going to enter in data. Then we can go again through what we have done. But we realized that mapping the standard was not enough, that just the use cases report what they have done. And then we organized a third internal workshop in order to push the partner to identify gaps, provide recommendations, give the impact. So during one of our General Assembly, we organized a physical workshop in order to capture more data from the consortium, from the members. So I think you can see here how we organize this workshop, very interactive with murals, post-its, and animating participants to contribute and write. So just during 1 hour, we developed this workshop. I can share you how we structured the workshop because it could be a best practice for other projects. We use World Cafe dynamization workshops that I thought that it's working quite well for the purpose of the meeting. So the World Cafe consists on organizing 3 tables, round tables, and then move the people on the 3 tables and have a moderator for each table. And we asked 3 questions to be answered during the World Cafe. The first question was, which standards are you using in Dat4.Zero and why? Which components and technologies in which use cases have you applied this standard? So you can see in these murals, we put this question and we ask people to contribute with post-it. The second question was identify standardization needs and gaps. And the third question was provide recommendations for standardization bodies. So as I commented, in order to answer this question, we use the methodology of World Cafe, consisting on creating 3 tables with 2 moderators in each table. The first table was about quality management standard, moderated by Ideco and Polimi. Second table, data management standard, and third table, use case standards. So, and we ask all the attendees to the World Cafe workshop to answer these questions in all the 3 round tables. So after 10 minutes, 15 minutes, it depends on the time available, we move to the next table, then everybody participate and contribute to provide answers. So here you can see quality management picture. Okay, I am going to skip it and just going directly to data management that was led by Holonix because they are the coordinators of Work Package 3, where we are implementing the platform for data management. So here with this workshop, we capture some standards that were not identified. You can see standard for data management, for secure industrial automation and control, for industrial networks, information technology security techniques. And also for data exchange, we also identified the deliverable that contains a standard related to security. Standards for data exchange, such as commented before, OPC-UA, FTP protocols, or MQTT. So also data quality standards related to data processing, for data gathering. So, and then the impact and the needs of these standards. So here we identified that it was necessary, it was an implementation of a solution for cloud orchestration. So Tosca edge computing and cloud orchestration is missing. So this is something that needs to be further developed. Also, explainable AI was an interesting topic for data management. And also there is the necessity, the group identified the necessity for traceability and accountability data management in projects. And also we identified that for secure data sharing based on IDSA, real-time data exchange standard was missing. And I have to say that is something that with the new data space protocol, it's solved. But also making data fair with data management plan, how we can standardize the data management plan in projects, data tracing. So a lot of needs and gaps were identified. And then we, here you can see some examples, okay? So, and then we are going to organize a workshop where we share in more detail all these recommendations. Here you can see a summary of all recommendations, not just for data management. And then we plan to share all this information with standardization bodies, standardization experts in a workshop at the end of February. So I recommend you to follow Dat4.Zero project in order, and also IDSA, because we will communicate in our social networks the information regarding this workshop that I think it could be very interesting for all of you. So then regarding standardization activities, pros and cons, okay, let me share with you the cons that we identified during the project. So we realized that there is a lack of standardization awareness. So the partners at the beginning of the project, when we started the standardization activities, the partners were not familiar with standards and how to implement it. They asked us support on how to implement standards, and they didn't have a clear strategy how to address these standardization activities within the project. So we, in order to manage it effectively, so we spend time in order to make awareness, to organize internal workshop, to share this common standard. And this was another problem, that when we asked for contribution for standardization reporting, very few partners contribute, and the contribution was suboptimal. So we educate also the partners on how to contribute to the standards, how to investigate internally if they are contributing to standardization bodies, because maybe the persons that participate on the project, they are not contributing, but they have people inside their organization that are actively contributing. So we initiate some countermeasures in order to address these problems. And we are learning and we are going to share this best practice in order that other projects can benefit of this experience. But then we have also pros, good practice. For example, successful cases. We had a previous project where we were collaborating in a cluster that make a sectional performance on standardization efforts on the project, and we learn a lot from them. For example, zero defect manufacturing platform, and we participate in clusters. So in standardization activities, the knowledge sharing, cluster participation, it's very important. So establishing standardization cluster for sharing data acknowledgement, and also for data management and standardization will be very important and will contribute to a significant efficiency in implementing data management standards and enhancing collaboration. So I recommend for future projects to establish this cluster. And then it was super useful for the project. The recent Sensenelec activities in collaboration with the European Commission to initiate workshops to support standardization activities. So I encourage you to involve to the Sensenelec workshop in your topic. For example, regarding data management, there is one activity in Sensenelec related to data spaces for the trusted data transaction, and I encourage you to contribute to this activity when the paper that we are finalizing before summer is public available for providing feedback. And also in the field of manufacturing, there are several Sensenelec workshops, and from Dat4.Zero we are contributing in a Sensenelec workshop on zero defect manufacturing. So this is one of the standardization bodies, committees, that we plan to liaison in order to share the recommendations and best practice from the projects. And also another important best practice, as I commented before, was the organization of internal workshops in order to engage the consortium members in a standardization activity. So without these internal workshops, we could not achieve the performance on a standardization that we have get the contributions and the commitment and feedback. So I encourage you to organize these internal standardization workshops. And now, finally, we are going to organize an external standardization workshop with standardization bodies that I have commented in order to share the recommendations, the gaps, the needs that we have identified. And that's all from my side. So thank you very much for attending this, and I encourage, as I commented, to follow us in the website. Thank you.
Sylvia, thank you very much for your wonderful presentation. Quite a lot new knowledge for us. Really important things to know. And for sure, we are going to take your advice and expand our knowledge more on your work, and especially on industrial data spaces. Now we have Roberto from Modular, who is going to present us the work they have done so far in the project, and especially on the semantic model that they have to design in order to save a variety of data. Roberto, the floor is yours.
Hello all. As Costa said, I'm Roberto. I'm also an employee in Holonix, and I'm currently working on the modular project. There are several tasks that they need to be done, and I'm gonna present a part of our work today. But first, let's start with what is modular. So, modular is the name of the project, which focuses on the industrial manufacturing strategies for distributed, controlled, resilient, rapidly responsive, and reconfigurable supply chains. It's a bit industrial wording here, I know, but keep up. So, it's an ongoing project, as we see. It started at the 1st of January of 2023, and it's currently ongoing, and we are traversing the 13th month of the total of the 42. And it derives of the principle of European Union, which strives to become more productive with less, something that traditional manufacturing systems are unsuitable to meet the new think small paradigm. So now, the modular envisions reliable, maintainable, affordable, and reusable and changeable SME-friendly autonomous modular factories and supply chains, able to manufacture new product in low volumes and rapidly respond to unexpected events, as well as the overall supply chain. We see here these pillars, which is the modular that focuses on these 4 pillars, offering hardware and software components. Well, we can see that the first pillar is the resilience against changes in customer and societal demands and distribution of the supply chain. Pillar 2 is the modular technologies for flexible manufacturing operations. Pillar 3 is the simulation and interfaces to the industrial metaverse. And pillar 4 is the human-centered technologies and the upskilling. Now, about our work. Holonix has the responsibility of developing a semantic ontological model, as we see here, focusing on creating explicit knowledge about the manufacturing process lifecycle, like the placing of an order, design, the suppliers which are going to be involved, the planning, the production of a product, and the whole phases. Well, everything that you can think on the industrial sector. It is based on the semantic web service wrappers as a foundation of interoperability in closed-loop product lifecycle management. An article of Procedia, CRP, which was published in October 2014, and it was written by Biba. So, it closely follows the principle of the OLM dataset standards, which translates to the Open Things Lifecycle Management, and it's a standard of the management of the data collected during the various phases of the life cycle of physical objects created and maintained by the Open Group. Again, if this is a bit complicated to understand, imagine that as a simple piece of information is usually distributed over many different services and devices and systems and organizations. Now, think this OLM like an ultimate authority that will not let this information to circulate before it transmutes and mutates in a form that can be understood and exchanged in a universal way by all the information systems that need to manage such usually Internet of Things related data. So all this standardization with the OLM will facilitate the raw data uplifting from the sensors in industrial site to a comprehensive, easy readable and ready to use form of semi-structured data to be used in applications like data analysis, creation, and structured data, focus on the detail, and etc. So we see several things here, and you may wonder what is this. Yes, again, to break it into layman's terms. This whole process aims to sanitize, improve, and present the data in a form that a variety of data systems can manipulate, store, exchange, and consume the data without worrying of how to do it individually in terms of quality, structure, and accessibility. Overall, data uplifting aims to enhance the quality and usefulness of the data, enabling better decision-making, analysis, and insights. This is achieved by defining the model of the structure of the presented data, which programmatically follows several steps to fill in the appropriate fields with the raw data and then to exchange it with the rest of the data systems to use it according to their needs. We'll come back to this later on, so don't worry if you didn't grasp it. Well, of course, this comes also with some compromises. As we enjoy some semantic clarity and standardization, this comes with the cost of the complexity and integration challenges, because we need to deal with a very different and in many cases, old systems that produce different type and formats of data. Same goes for the different aspects of what we can have with this model, like that the flexibility needs constant updated evolution of the model to cover the newest additions and changes of the data, as well as the comprehensive knowledge representation of the data comes with heavy semantic ambiguity, which leads us to revise the model again and again to be sure that we can include different types of data. Lastly, the interoperability that provides this model, which can be applied to a variety of systems that follow similar standards and have the understanding between them, comes with often heavy computations which deplete the computational resources of the systems, thus putting some restrictions on where it can be used, especially on the old machines and systems that were built several years or even decades ago. This will apply for our three use cases, the pilots that they are involved, like the first, which is the FFT, a producer of printed circuit boards that needs several manual steps into the production line and aims to diminish the human effort in parallel of cutting down costs and production type. Then we have EMO, an industry that creates tools for automotive, aeronautical, and aerospace industries. Their aim is to detect the failures on the production steps as early as possible. And lastly, we have NECO, a tool manufacturing company that currently they provide the use case of the production of taps. It's a tool that drills a hole in a material so you can insert a screw. And they aim to achieve a flexibility on switching to a different type of end product, minimizing the time of the reconfiguration of the production line. With this is an initial introduction of the whole idea of modular. And we can continue now with the more technical aspects that we as Holonix are focusing on. Give me a moment so I can prepare the next slides. And we're ready. So, as we said before, Holonix has the task and the responsibility to develop a semantic ontological model, focusing on creating explicit knowledge about the manufacturing process lifecycle. What this means is that when several services will communicate between them, there must be a standard that defines the relations and constraints without a domain of knowledge. In our case, the life cycle, making it easier for machines to understand and reason about the information. We also said that it's based on OLM dataset standards. What we didn't say is that it's written in a descriptive language which is called OOL, an anagram of web ontology language, so that it would choose the animal that expresses wisdom of knowledge, as you see, bottom right, according to the ancient myths as a symbol. The basic concepts of this language is that we define the classes, representations of physical entities and properties, which are the relations between the classes, and they are divided in two groups. There are the object properties that connect two or more classes, and data properties which associate the classes with several values. And in the end, the individuals, which are the instances of the classes, and they flesh out the actual entity that we can interested on express of the ontological model. The example that I was eager to show is a bolt, a simple piece of metal used as a fastener to secure firmly two pieces of components of a construction. It can have several properties, like the type of a raw material that will be used to produce one, the shape of it, as there exists also the U-shaped bolt, so it is not just the straight one, but you can have several different types for all the cases that you need to fasten the two components, thread diameter, etc. All these properties can be described as a collection of data from the sensors and systems of the factory, and the ontological model will assure that the rest of the services that will pull this data know that we are describing the bolt entity. Now, to properly introduce these entities from the pilot data, here we are again with a methodology that we were thinking before, because this methodology is needed to feed the model with accurate and comprehensive data. The data uplifting, as we see here, comes to fill this need with the idea that if we follow several directives on how the data has to be presented, then we can safely assume that it can be used to produce accurate knowledge for the manufacturing process lifecycle. This is needed because we risk to have dispersed data to several partners, which they'll follow their own methodology of organization and store the data, will come to a point that two services that need to communicate will not know how to exchange the data. As you see here, several partners or several companies or even services, they may have their own standards, which also this will unnecessarily elevate the complexity. You cannot keep track of what customized solutions each one of these partners or even services have. So the whole ecosystem will have unnecessary complexity, as we said before, and this will lead to a problem that we need a lot of time and resources and to spend on an agreements between the interested parties to harmonize their data exchange. That's why we are focusing on the data uplifting. So we're gonna set a standard, and thanks to it, all these partners and all these involved parties will have something to rely upon. To do this, we focus on the LinkML. This is a module, take it as a library of Python, which creates, manages, and uses data models that standardize the presentation of the data according to our needs by simply feeding the YAML template, which is created entirely by us and have the ability to be as flexible as we require to introduce newest pieces of data. As you can see also here, this is a little piece of the code, which set the standard that you cannot deviate of this. You need to feed the data to get it, to transmute it, and also to uplift them before you can ship it to the next part of the whole service or even of the whole modular architecture. The compatibility that provides with the resource definition frameworks is an excellent opportunity to fill our needs, as the OLDL language that we are utilizing for the ontology model description can describe the semantic ontology model, which is based also in the resource description framework, the RDF in short. Once the data have taken their final form, it is entirely up to the rest of the partners to consume the data in a way that they see fit, like, for example, to store it in a database or even to show it on a website, as we see here a small mock-up. Having a standard on how the data is represented enables the smooth collaboration of the services that comes after our part. Holonix is also tasked with the development of the infrastructure of the persistence system, which will be responsible of keeping and distributing the data, as well as representing the knowledge. This is still under development though, as we need to follow the big data management principle because of the nature of the data, which are industrial sensors, output, and are characterized of the high velocity and the volume, which is quite a lot when we are talking for industrial scale solutions. The suggestion in this case is to use Caron, an internal product which is in a high technological readiness level and flexible enough to manage the data in a variety of databases. It can manage inputs from the edge-to-fog communication middleware, which will be developed from another partner, adding the necessary metadata and preparing them for the distribution. As for the access of this data, there is an ongoing research upon the layer of the elements of the International Data Space Standard, as you heard before, specifically the connector that they are using, which will be used for the authorized third-party data exchange, enabling the intercommunication between the different factories and organizations. This layer also will provide the data of the training and training phases of the machine learning algorithms and other data analysis related tasks, which will be deployed in later times. And with this, I hope that this short introduction was also comprehensive and very descriptive. Back to you, Costa.
Give me a second, please. Thank you very much, Roberto, for your wonderful presentation. As we have seen that IDS is in both projects, both in modular and Dat4.Zero. Now I will present the standardization in the KITT4SME project and the work that we have done there and what we have achieved. So in KITT4SME, the goals in standardization were very specific. One is developing a data model that was accepted by the Fireware institution as a smart data model. The second thing that we did is that we participated in to the HS Booster Service. That is a 30-month European Commission initiative that will provide the European standardization booster, and it comes by providing expert services to European projects to help them to increase and valorize project results by contributing to the creation or revision of standards. We discussed with them, we talked with them, and we got some feedback from them. And the third thing that we did was having this podcast and exchanging knowledge with other projects. So when it comes to pros and cons in the KITT4SME related to standards is that we have used a lot of different standards, but all those standards are IT standards or standardized communication protocols and so on and so forth. About the industrial standards, we couldn't use them due to the fact that a lot of the machines, especially the machines that live to the pilot's shop floors, are old or they don't follow any standards. Additionally, we wanted to use AI standards provided by ISO and IEEE, but most of those standards, if not all of them, are still in preview mode, and the AI developers were not aware of them or felt somehow reluctant to invest more time in them due to the fact that, as I said, they are in preview mode. As you can see, in this table, we have incorporated the previous standards that come from these various organizations, but as I said, these standards are all of them IT-related standards, and there is nothing that comes from manufacturing. Now the time has come for questions. I would like to ask you the following question to both of you. In the past 2 years, well, actually, in the past years, due to the fact that all of us had to stay home because of COVID, this also had an impact on the European companies and especially the SMEs. As we all know, the European SMEs, some of them are family businesses, they are small, they are old, and they are not, let's say, willing or persuaded to invest so much in digitalization and in AI technologies. And this is something that we have seen through our projects, not only in lack of standards, but not knowing that some standards exist or are willing to apply them into their companies. How difficult or easy is to talk with SMEs that are, let's say, reluctant to invest in that? Sylvia, ladies first. You are muted.
Okay. You are right that for SMEs it's very difficult to invest and to know how to cope with the digitalization and how to implement it in the projects. So this is something very important and at the same time challenging. Okay, so we in fact we realize of these difficulties for the SMEs, and in the project that we are participating fortunately, they have very good technological research center close to them that supports and introduce them to these activities. So that's great. And recently, I was with an SMEs talking regarding data management. That is the topic of this podcast, and we were explaining how to enter into the data spaces, and they were not aware about data spaces. So for the SMEs, the secure data sharing is not an easy topic. So what I recommended them, because they are part of a new project starting now and they are going to implement connectors, but they have the support of a technological research center, but the recommendations for SMEs on this digital field and regarding data management and secure data management is start to treating the data as an asset. So to identify which data is valuable for them and classify this data and generate metadata in order to be easy treated for other systems and share the data. So this is something that if they cannot do by their own, they can ask support to companies on how to manage the data internally and be ready for sharing the data with externals. For the companies that have already has the capacity to share data with externals and participate in data spaces, then a new problem comes is how to implement the requirements of data spaces. So for implementing data connectors, as Holonix, you have experience, so you can provide recommendations or assessment how to implement the connector or in your platforms or your solutions. But in IDSA, and let me share with you, in IDSA, we already identified this problem. I'm Fraunhofer, for example, And there is one startup, this is a spin-off from Fraunhofer, it's called Sobity, that they are providing data spaces as a service. So you can go to the webpage, sorry for the for the promotion, but just to show you. So you can go to the website and you can use a connector as a service for your benefit. So these kind of solutions are very useful for SMEs in order to implement and access to data management in a secure and sovereignty way.
Roberto?
Yes, as for me, well, here comes a lack of the whole understanding of the Horizon projects, because I will speak mostly from the corporate side. So it will be heavy influenced what I'm gonna say next from the corporate space and from the private sector, which is all this run for the AI is using some new technologies is always in the agenda of these companies in order to be in front of every technological revolution and be ready to provide solutions and products and whatever they need. But the problem, and the biggest one, is the capital. How they're going to invest in it and how much of it they're going to invest. So there is always a reluctancy and the skepticism on the newest technology whenever it is announced, because most of the time they want to have some to gain some space in order to have their research as safe as possible, and also to give some go on and head starts on a competitor in order to see how it's gonna fare. And when the whole product will mature, then to follow up and maybe to evolve it into something which is usable. All this comes all with the same idea. Let the others try and fail, and we're gonna get the final product, which is usable and ready to be sold. So if you ask me, yes, I noticed from time to time reluctancy on some companies that they don't want to incorporate and also to include in their services and products and whatever these new technologies, or they are given this and that.
Thank you very much, Roberto, for your answer. It is true. I share the same feeling that there is that the European companies are reluctant somehow to invest in a brave way into artificial intelligence and whatever comes to that, like standardization, for example. One more question by my side for both of you. Since this session, this podcast session is about standardization and data management, one really important aspect that we have to face is the data protection, the data anonymization, and in principle, the whole GDPR philosophy. On the other hand, we have AI models that need a lot of data, that need a lot of data in order the AI models to be trained and produce valuable results. The standardization can play an important role in securing that the GDPR is going to be respected, or will focus more on the business needs and I'm not going to say violate it, but let's say create some weak principles that might not be respected by everybody.
Sorry, I didn't catch your question appropriately. So, so what do you mean that it is not going to catch? So, can you repeat?
Yes. Do the standardization bodies take GDPR under consideration or not?
I think that GDPR is a must. So it's not the standardization bodies that should take care of it. It's the company that has to implement it. For example, in IDSA, we are not standardizing GDPR because there is a rules. It's a commitment. So you have to fulfill it. So we don't need to standardize. Okay. So you need to follow a procedure you need to fulfill the GDPR. Okay. And maybe this is not our field because we see that this for data sharing, okay, this is a rule that should be implemented at company level, at use case level. Because so if you talk about the necessity for security, you commented anonymization, data protection. So what I want to answer your question, contributing to explain why data spaces are needed in manufacturing sector, because we realize that companies don't have this necessity because they don't share data. So you can talk about data security, data anonymization, but in real, the problems that we have also in research projects, in test bed environments and controlled environments, is that the companies doesn't share data because data has a value for them. Data is important for their business, and they are not secure what you are doing with their data, how you are going to manage the data. So here is not just a question of anonymization. It's not a question of security. It's a question of trust. So you have to provide tools and standards for companies in order that they can trust what you are doing with their data is what you have agreed. In order to understand, it's the same that with the money. So I have commented before that we need to educate SMEs to treat the data as an asset. Treating the data as an asset means that the data has a value, and you need to protect, to identify the value of your data. And how you have to be able to share your data with other partners in order to create this added value service. And then we need to provide these SMEs the trust and the standards to share this data in order that they can control what is happening with their data. So it's not just fulfill anonymization, data access. We go beyond data access. We implement this anonymization and data access, but we go beyond with data usage control, data policies agreement. So contracts negotiation automatically. This is what IDSA contribute to the deployment of security for trusted data and sovereignty. Data sovereignty, you keep the control. That's all from my side.
Thank you. Thank you very much, Silvia.
Yes, I would say that the two main points that we have to respect the GDPR and that it depends on the trust of all the partners are the two main answers also that I can fill my part. Yes, and speaking about it, you can always have methodologies of how to anonymize data. This has happened a lot in the EdTech, which you have data from small kindergarten kids that they are attending the kindergarten to the university students and alumni. So in order to not targeting those, you have methodologies, you have standard practices that they are working fine, and you can always clean up the data and anonymize it. But it takes time and effort. This is the question, if everybody gonna invest on this. And secondly, if is not, and because the AI essentially is quite a new technology. If it needs data and as accurate as possible, then you can always resort to synthetic data. This is my take on this, and that is my answer.
Thank you. Thank you very much to both of you. I don't have any more questions to ask you. I believe that we have covered almost everything from the standardization process itself, the standards, and the everyday reality of how these standards could be, I'm not going to say enforced, but embraced by the SMEs, but also by the community and the society in general. And indeed, the security aspect and the data management and the data security is a huge aspect that for sure we are going to discuss it in other Horizon projects too. Thank you very much for your time. Thank you very much for your wonderful presentations and the knowledge that you shared with us. And we might meet again in a future podcast. Have a nice day.
Thank you.
We also thank you for the invitation.
Thank you.
Have a nice one. Bye-bye.
Bye.
Bye-bye.